1/1000th of an inch. Whew. See, now they're going to look at you with respect, Dave. So, having told you about the science that went around back then, let me give you some idea of the science going on at Nevis now. Nevis has had a long history of working with various different particle accelerators, particle colliders, rather. I should mention the Hera Collider in Germany, located at Daisy. We worked with them. That's a proton on electron. We were involved, I mentioned already, the Tevatron, for many years the highest energy particle accelerator in the world. Nevis was involved with that, and it is well known for the discovery of the top quark back in 1996. But presently, we are working with a big collider experiment, the Large Hadron Collider, which is currently the most powerful particle accelerator in the world. John Parsons talked about that in the first of the Science-on-Hudson talks exploring the universe with the Big Bang machine. I should mention again that all of these talks that have taken place, or at least most of them, haven't gotten around to Leslie's talk yet, have excerpts which appear on our YouTube channel. Just go to YouTube and look for hashtag Science-on-Hudson and you will find them. We also have had decades of experience working with the neutrino program, both in using neutrinos to understand the properties of other particles. As Mike mentioned, my doctoral thesis was using neutrinos to understand the structure of the proton, and also learning more about the properties of neutrinos themselves. And Leslie talked about this last month in his talk, Neutrinos, a particle with identity problems. We're also involved in experiments with very high energy physics. Again, have been doing so for decades. One category of these experiments involves using the largest particle detector that we presently know of, the Earth's atmosphere, and looking for cosmic ray showers in the atmosphere. Experiments like high-res and Auger. Reshmi Mukherjee gave a talk on Our Violent Universe discussing Veritas and CTA, two experiments with which Nevis is associated with. Another relatively new way of looking at very high energy phenomenon in the universe is to use neutrinos. In Antarctica, we have a neutrino telescope called IceCube, a kilometer-sized block of ice, all instrumented. There are some panels here on the side of the room that describes that. Mike Shavitz talked about this in his talk, Fishing for Neutrinos at the South Pole. I mentioned RARAF before. They have the world's foremost microbeam facility. They just don't irradiate cells. They can send a single particle targeted to a single organelle, a single structure within a cell, and then observe the effects of radiation damage due to that one particle. Yeah, very impressive work. The talk was called Radiation at the Small Scale, looking at the big picture. You might want to look at the YouTube just for that one alone. There's work being done by the Columbia Astrophysics Laboratory on the first chemical reactions that occurred in the universe. The talk was The Chemistry in the Cosmos from Daniel Savin's group, and we learned how the first elements were formed. We have also been involved in several exotic matter searches. The most current one is the hunt for dark matter using the xenon experiment, a great big tank of liquid xenon. Elena Aprilli gave a talk on that. Next semester, we are going to hear from the nuclear physics group. Okay, you can collide protons with each other, and electrons with each other, and so forth, but you can also collide big atomic nuclei with each other. Only a particle physicist would refer to an atomic nucleus as big. Here you see a picture of two gold nuclei colliding with each other and producing showers of particles. And the goal here is to produce something that Mike mentioned, quark-gluon plasma. That is a state of matter that only existed in the first instance of the universe, and tells us something about how the universe was formed. Brian Cole, next semester, will give a talk on looking for primordial matter at the LHC using the same detector at atlas that John Parsons there uses for proton-proton collisions, but instead looking at nuclear-nuclear collisions. It should be a very interesting talk. Nevis was involved in building equipment for the NuSTAR satellite, whose purpose was to measure X-rays, and that satellite is still in orbit and still gathering data now. We have also done work in exploring the microwave background. Her experiment also takes place in Antarctica. IceCube isn't the only chilly place that we go to, is the only one that has the monopoly on Antarctica, and it's a balloon experiment, as you can see from the picture. Now, after going over all of this science, perhaps I should say, Mike Shavitz is standing over there, and I'm going to get a lecture from him after this talk, because I mentioned 9 different things and different experiments, and that's probably only about half the things that we have done at Nevis over the years. I left a lot of stuff out, had to. And in talking about the science, it's interesting, but some people are here for the history. Let's go back to the history of the Mansion House. As I mentioned before, by 1954,